Alright, well, one more night visiting our favorite chain rule here, and hopefully you're starting to feel a little more confident with it, and we'll just keep building throughout the year. So take a notes and enjoy. Alright, example number 1 tonight. Let f be a differentiable function such that f of 0 equals 2 and f prime of 0 equals negative 3. Now don't let this word differentiable scare you. All that means is you can take the derivative, which we know is true because they did right here. A. The function h is given by h of x, and again, read it out loud to yourself. H of x equals sine of ax. I said of, so I need chain rule. Times f of x. I said times, so I need product rule. For all real numbers, where a is a constant, find the value of h prime of 0 in terms of a. So h prime of 0 is saying, okay, plug 0 into h prime. So I need to plug 0 into the derivative of h. In terms of a just means I should see a in my answer. So I'm just going to bracket in my two products. I have the sine of ax times f of x. So I'm going to go product rule. So h prime of x equals first sine of ax times the derivative of the second, so times f prime of x, plus the second times the derivative of the first. And if you have to rewrite it off to the side, that's okay too. The sine of ax is derivative of the outside, keep the inside. So cosine of ax times the derivative of the inside. Well, think about that. If my inside was 4x, my slope would be 4. So if my inside is ax, I'm going to multiply by my slope of a, because a is a constant, remember. At this point, I found the derivative, and I'm just going to substitute in 1 into the derivative. I'm sorry, not 1, 0 into the derivative. So I'm going to replace all of my x's with 0. So I'm going to get the sine of a times 0 is 0, times f prime of 0, plus f of 0, times the cosine of a times 0 is 0, times a. Now remember, sine of 0 is hopefully one of your favorite numbers. Picture that sine graph. The sine of 0 is 0. So 0 times anything is 0, and that kills that term. F of 0, if I use this term and I look back in my directions, f of 0 is 2. The cosine of 0 is 1, and I'm left with 2a. And that's it. I have found the derivative h prime of 0 in terms of a. B. The function p is given by p of x equals, so again I'm just going to rewrite it and say it out loud as I rewrite it, x to the k power plus the sine of pi x. So notice again I said the word of. That means I'm going to need chain rule to take that derivative. For all real numbers where k is a constant. So picture it as like a 2 or a 3. If p prime of 1 equals 4, find the value of k. Okay, so I know p prime of 1 equals 4. That means I'm going to take the derivative, I'm going to substitute in the number 1, and I'm going to set it equal to 4. Alright, so here we go. P prime of x equals, okay, x to the k, and k is a constant. Well, if I said x cubed, could you easily take that derivative? Sure, you'd say 3x squared. I'm going to do the same thing, except instead of a 3, it's a k. So I'm going to bring the k down, x, and don't forget you have to subtract 1. So I'm just going to say to the k minus 1. Plus, this says sine of pi x, so that's my inside and my outside, so I'm going to say the cosine of pi x, keep the inside, times the derivative of the inside, so times pi. At this point again, it says plug 1 into your derivative and set it equal to 4. So I'm going to say 4 equals k, 1 to the k minus 1, plus the cosine of 1 times pi is just pi, times pi. As I continue to clean this up, I'm going to say 4 equals, now I have 1 to the k minus 1. Hopefully that's not freaking you out too much. What if I said 1 to the 10th power? Well, that just means 1 times 1 times 1 times 1 10 times, which is still 1, or 1 to the 3rd power, that's just 1 times 1 times 1. So 1 to the k minus 1, guess what, is just 1. times k, plus, I know the cosine of pi, picture that cosine curve, the cosine of pi is -1, and then times pi gets me actually a minus pi. So the direction said solve for k, so I'm just going to say k equals 4 plus pi. Oops. And that's it. So just read carefully on what to plug into what, and just really watch your words of, so you know when to use the chain rule and when not to. Next example. Let f be a differentiable function. Again, all that means is you can take the derivative, which they have here. They give us an f prime. Let g be the function given here. I have to apologize for this extra square root hanging out. Ignore that. Write the equation of the tangent line. So the second you see that word tangent line again, remember, you need an x, a y, basically a point, and a slope. Specifically to the graph of g when x equals 3. Alright, so I already know the x value is 3. Do I know the y value? Not at the moment, but I can easily get that. I just have to evaluate g of 3. So I'm going to carefully substitute this in. I get f of 3 plus 3 squared and the square root of f of 3. And then I'll just evaluate it. So I get, let's see, f of 3, if I read my rule, is 4. So now it really says f of 4, and f of 4 is 3. Plus this is 9 times the square root of f of 3, and again f of 3 is 4. So that's really 2. 9 times 2 is 18, plus 3, I get 21 for my y value. So I'm going to go and fill in my point there. Now I need the slope. Now I actually have to do some calculus. So right up until then I was just doing a little bit of algebra. Now the calculus part, remember slope is derivative. They mean the same word. If I'm going to derive or take a derivative, I'm finding the slope. So I've rewritten out my function so I can scroll up a little here. And I'm going to carefully take its derivative, but of course I'm going to read it out loud so I know exactly what I want to do. This says f of f of x. Therefore, when I say of, I know I have my chain rule. I have my inside and outside. This says x squared times f of x. So there's a product rule. And I'm really going to rewrite this as x squared times the quantity f of x to the 1/2 power. So I clearly have the quantity, so I have an inside and an outside. I have another chain rule. So I'm just going to slow down and take my time as I go through this. So g prime of x equals, let's start with this guy, chain rule, f of x. Derivative of the outside, keep the inside, derivative of the inside. The derivative of f of x is f prime of x. Then you've got a plus sign. Now, remember, I've got product rule here, and I just want to stress it again. I have x squared times this function. So I'm going product rule. So I'm going to say first term, x squared, times the derivative of the second. I'm just going to leave it blank for a moment, plus the second term, which is that square root of f of x, times the derivative of the first, which I'll leave blank again. All right, so I need to take, so I had first derivative of the second. I need to take this guy's derivative. We said it's f of x to the 1/2, so that's 1/2 f of x to the negative 1/2, but now times the derivative of the inside, which is f prime of x. Okay, so slow down and pause that, rewind it if you have to. It was f of x to the 1/2, so I brought the 1/2 down, left the inside, subtracted my 1, and then the derivative of the inside. Plus the second term derivative of the first, which is a nice easy 2x. Whew. All right, now I'm allowed to evaluate this problem, and I think we were finding, what was it, when x equals 3. So I'm going to say g prime of 3 equals f prime of f of 3 times f prime of 3 plus 3 squared is 9. And notice I'm going to rewrite this term as I plug it in. So my 1/2, my 2 goes on the bottom. This square root's going to go to the bottom. So I'm going to get the square root of f of 3 on the bottom. And then f prime of 3 on top. Plus square root of f of 3. And then 2 times 3, of course, is 6. Alright, I just had to recopy these down so I could see them and evaluate my function now. So I've got g prime of 3 equals, let's see, f prime of f of 3, and f of 3 is 4, so I've got f prime of 4, times f prime of 3, which is 5, plus 9 times f prime of 3, so that's 5 over 2, and I have the square root of f of 3, and I'm going to do that in my head. F of 3 is 4, its square root is 2, plus the square root of f of 3, so that's going to get me a 2 times 6. Now, just be careful with this one. This still says f prime of 4, and f prime of 4 is negative 1. So I'm getting negative 5 plus 9 times 5 is 45 over 4, plus 6 times 2 is 12. And as I clean that up, I can get my negative 5 and my 12 gets me a 7 plus 45 over 4. I'm going to get myself a common denominator by multiplying this by 4 over 4. So I've got 28 over 4 plus 45 over 4 gets me 4, 5, 6, 73 over 4. And remember, that represents my slope. So as I put all of this together, I've got y minus my y value equals my slope times x minus whatever my x value was, which I believe was a 3. And if I scroll back up, I think my y value that we found was 21. And there you have it. In our next example, y equals x divided by the cubed root of x squared plus 4. Now, if you love quotient rule and you want to attack it that way, by all means go ahead. But I don't know too many people that actually like quotient rule. So I'm going to rewrite it so I can do product rule instead. So I'm going to say this is really x times, of course, and I'm going to bring this junk from the bottom up. X squared plus 4. Cubed root is a 1/3, and because I moved it to the negative 1/3. Now, I just want to be clear that I have not done any calculus, and I do need product rule because it says x times this quantity. So, if you can pause it, that would be great, and just make sure your derivative is the same as mine. And hopefully you'll agree here I got x. When I took the derivative of this second term here, I saw a chain rule, because I have an outside and an inside. So that's where my negative 1/3 left the inside, subtracted 1 times the derivative of the inside, plus the original times 1, of course. Now, we've been doing a great job so far in the past 2 days here, and I just want to really stress our factoring now. Okay, it's all about the GCF at this point. So just to be clear, I'm going to look at this side of the plus sign and this side, and I'm looking for something they have in common, and I hope you would agree it's the quantity x squared plus 4. And remember, I need to pull out the smaller, and I would say negative 4/3 is smaller than the negative 1/3. Okay, now I make a nice bracket, and I write in what I have. If I took this out completely, and I multiplied this term, and this term, I would get negative 2/3 x squared. Then I have this nice plus sign, and if I took this out, remember it's what you have minus what I took out, minus my 4/3, negative 4/3, which of course turns into a plus, gets me 3/3, and yes, that leaves me with one of those, so I'm going to say x squared plus 4. Lastly, I'm just going to clean this up a little bit to make sure my multiple choice answers. I can add negative 2/3 x squared, and of course I'll call that 3/3 x squared. And that leaves me with a 1/3 x squared plus 4. And this other stuff I'm just going to move to the bottom and call it the cubed root of x squared plus 4 to the 4th. And lastly, the one thing you're not gonna see on any of the multiple choice answers is like a complex fraction, which we have here because of this 1/3. So I'm real quickly going to multiply every term, or basically the entire top by 3 and the entire bottom by 3, and that will kill that fraction. So I would say if I distribute that 3, I'm left with x squared plus 12 all over 3 cubed root x squared plus 4 to the 4th. And there you have it. That is as simplified as I need to get. Alright, I just wanted to run through a couple more little chain rule details, and hopefully we're good to go. So, Again, this says g of f of x. That keyword of tells me chain rule, and I have an inside, the parentheses, and an outside. So the derivative of y, remember you can either call y prime or dy dx, okay, equals, say it in your head, derivative of the outside, derivative of g is g prime, keep the inside, times the derivative of the inside. And that's all I'm looking for. I just want to practice cleaning some of these up. Let me try another one. If I said y equals g squared of x. This is similar to that trig function. Watch how we rewrite this. And remember that rewrite's so important. Notice my square is on my g function. So I'm going to rewrite it as the quantity g of x squared. Now I haven't done any calculus. I'm just taking that super important step on rewriting. Now I'll take my derivative. Notice it's the quantity squared. When I say quantity, again, that's implying the chain rule. This is my inside and my outside. So I'm saying dy dx equals derivative of the outside, that's a power, so power rule, 2, keep the inside, raised to the first, now times the derivative of the inside. And that's all I'm looking for. We're just going to practice that chain rule. Number 3, y equals the cubed root of f of x. So again, I want to practice rewriting. This is really y equals the quantity, f of x, raised to the 1/3. Okay, now we have, again, this is the quantity, that's my inside, this is my outside. So I've got dy dx equals 1/3, I'm doing the power rule, keep the inside, raised to, I'm going to subtract 3/3, so to the negative 2/3, times the derivative of the inside. Now, don't forget, when we have these negative, ugly exponents, let's clean it up. I can say to myself, the 1 stays on top, 3 goes to the bottom. This is going to be the cubed root of f of x squared. And then I'm going to leave f prime of x on top. Okay, so just watch your cleanup step. And technically, I would plug a number in on this part. I always clean it up before I substitute anything in if they had given me a problem like that. All right, let's see one last one here. Let's say y equals the sine of cosine of x. All right, is it clear we have chain rule? I have an inside and an outside, and I said the word of, the sine of cosine of x. So here's what we're doing. We're saying y prime equals derivative of the outside, keep the inside, times the derivative of the inside. The derivative of cosine of x is negative sine x. So just make sure you pull that negative out front. We cannot leave it in the middle of a problem. So I'm going to say it's negative sine x, you can pull that all out front, times the cosine of the cosine of x. All right, well, we'll get a lot more practice in class tomorrow. And just, it's okay to talk them out loud. So just keep practicing, and we'll see you tomorrow. Have a great night.